All right, we're going to take a look at the discriminant. So what is the discriminant? Well, when you learn the quadratic equation, which of course is negative b plus or minus the root of b squared minus 4ac all over 2a, you know that the stuff under the root, which is called the discriminant, will determine the nature of the roots. If this is a positive number, you know that you have something that looks like this, a graph that has 2 cut through the x-axis twice. If you have a negative under here, you know the picture is that you don't actually have any x-intercepts or roots, because you can't take the negative. A root of a negative number. And if this equals 0, then it just touches the axis and then bounces back away. So some examples are, for example, here you can take a look and see that when you have a question like this and you complete the square, you can see it's in vertex form. What the vertex is 3, -1, 3, -1, and the curve cuts the x-axis twice, so we know that the discriminant, or the stuff under the root, will be positive. When the curve just touches, it will be 0, and when the curve doesn't touch at all, it'll be negative. The language we use is when the discriminant is positive, we will have 2 real, different, distinct roots. When the discriminant is 0, we say we have 2 real equal roots. I'll tell you why in a second. And when we have the discriminant is less than 0, we have 2 non-real distinct roots, or just 2 non-real roots. Let's go back to this again. Why? Because here we already know exactly what it means, that we don't see any touching of the x-axis. And of course, you could also have a graph that looks like this, and it's down there, right? The little x and y axis. Here, you know this equation here where it says y equals quantity x minus 3 all squared. You know you could also have it like this, y equals x minus 3 times x minus 3, because x minus 3 all squared is that times itself. So because the roots are 3 and 3, even though it looks like it just touches once, and it does only touch once, that's why we say we have 2 real equal roots, because we have 2 roots, they're equal when we do the algebra. Okay, so now sometimes you're going to be asked, instead of finding the roots, you're just going to be asked to find the nature of the roots. Are there 2 distinct real roots? Are there 2 equal real roots? Or are there no real roots? So what we need to do is we still need to find out what A is, B, and C. But then we only put them in the discriminant, b squared minus 4ac. We sub it in. -2 minus 4ac. And that's 4 minus, what's that? 21 times 4 is 84. Anyhow, we don't even need to simplify, because we can see here that this is going to be less than 0, and therefore no real roots. Determine the nature of the roots, then there are no real roots. This one, you can do it. You can find that there are either 2 real distinct roots, 2 real equal roots, or again, 2 no real roots. Okay? And if it's not given to you in standard form, you have to rearrange it. So here, what we're going to do is we're going to bring everything over. So we have -x squared minus 5x plus 4 equals 0. So A is -1, B is -5, C is 4. And then we have b squared minus 4ac equals excuse me, 4ac. Now let's see what happens. 25 minus and minus is plus 16. Again, we don't even need to add if we don't want to. We know that this is greater than 0. So therefore, two real distinct roots. Something tells me here we're going to have two equal real roots because we're doing one of each example. So here we're going to rearrange. We've got 4x squared minus 12x plus 9 equals 0. A is 4, B is negative 12, C is 9. B squared minus 4ac equals B squared minus 4ac. And we have 144 minus 36, 72, 144. And what do you know? We end up with 0, and therefore two real equal roots. Okay, now let's see what they want us to do here. Here it says, determine values for k that will give each of the following equations the indicated type of solution. So here we have for A, x squared minus kx plus 3 equals 0, and we want equal roots, real equal roots. That means that we have to have b squared minus 4ac equaling 0. Well, we have here that a is 1, b is negative k, and c is 3. So let's sub it in. B squared is negative k squared minus 4ac. So negative, what am I doing here with this equal sign? So now, negative k all squared is k squared. This is minus 12 equals 0. K squared equals 12. So k equals plus or minus root 12. But of course we know root 12 can be broken down to 4 times 3. And then we take out the 4, so it's plus or minus 2 root 3. And that's what k is equal to. Let's do b. We have kx squared plus 3x minus 5 equals 0. So a is k, b is 3, c is minus 5, and we need no real roots. So we need b squared minus 4ac to be less than 0. Okay, so we have 3 squared minus 4ac be less than 0. That's 9. Negative times negative is plus. That's 20k less than 0. 20k is less than negative 9. Divide both sides by negative 20. By 20. So k has to be less than negative 9 over 20. And then the last one I'm going to leave for you. It says 3x squared plus 4x plus k equals 0. I'll write it out here so it's a little bigger. You might be having some trouble seeing this small print. 3x squared plus 4x plus k equals 0. And we want real distinct roots. So we know that b squared minus 4ac is going to be greater than 0. A is 3, B is 4, C is k. Figure it out. You've got this. And that is the end of this unit.